Hi everyone. Today let's discuss about the problems and solutions of Unit 8 Organic Chemistry, some basic principles and techniques. Even though the solutions for these questions are given in the textbook, our explanations will give you more insights on how we arrive at these solutions. Okay, so let's start with the first question. How many sigma and pi bonds are present in each of the following molecules? Okay, let's first write the complete structure of the molecule. Okay, I mean with all the bonds, so that we can understand how many atoms are there and how many bonds are there, right? So CH and then CH H. Okay, so in this case let's understand that uh, these are the sigma bonds. All right, this one is a sigma bond, this one is a sigma bond, and this one is a sigma bond, right? These are all sigma bonds which share two electrons. Okay, so now let's count the bonds. First, how many sigma CC bonds are available? Okay, so carbon to carbon, how many bonds are available? Let's count. Here we have, I will change the color. Here we have one bond, then two second sigma bond, then third sigma bond, then fourth CC sigma bond. So how many are there? So total number, there are 4 CC sigma bonds are available. Okay, now let's calculate the CH sigma bonds. Okay, sigma bonds CH, how many are there? Here if you look at the total number of CH, here is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So 6 CH sigma bonds are there, right? Next let's check the pi bonds. How many pi bonds are there? There are only one types of pi bond here, which is C double bond C. Okay, how many are there? We have one pi bond here, and the second one is over here, and third one is over here. So there are 3 pi bonds are available. Okay, let's look at the second molecule, CH double bond C double bond C H C H. Okay, so if you look at here, how many bonds are there? How many sigma bonds are CC? Okay, we have 1, we have 1, 2, 3. 3 CC sigma bonds are there, right? 3. Then how about sigma CH bonds? We have 1, 2, 3, 4, 5, 6. 6 bonds are there. And then how about the pi bonds? Sigma, sorry, pi CC, how many are there? We have 1 over here, 2 over here, so only 2 are there. So to answer questions like this, we have to write the full structure, I mean complete structure of the molecule, so that we will know how many bonds are there, right? Let's move to the next question. Second one, what is the type of hybridization of each carbon in the following compounds? Okay, for this we have to understand the structure again. Okay, so let's write down the structures. HCl, okay, and then C double bond O, CH3, CH3, and then the third one H H H, and then a carbon which is in triple bond with the nitrogen. Then the fourth one, C double bond O, hydrogen, and H2, right? And the fifth one, C. So the most important thing is you should know how to write the complete structure. Okay, complete structure is very important to further investigate the property of your molecule. Okay, so these are the structures of the given 5 molecules. Okay, now let's check what are the hybridization for this. In the first molecule, methylene chloride, here we have only one carbon atom, and the question is that what is the hybridization of carbon, right? So here this carbon is attached to four molecules, okay, 4 atoms. So when carbon is attached to 4 atoms, then the hybridization is called as sp3. Okay, in this case, second molecule, we have 2 carbon atoms. Okay, this carbon atom is attached to 4 atoms, right? One CO, 3 CH3. So this carbon has a hybridization of sp3, and here this carbon is attached to only three atoms. One is this carbon, other one is this oxygen, and then other one is this carbon. So when carbon have only 3 atoms, then it is called as sp2. All right. So when it comes to this molecule, here we can see that, as usual, similar to the first one, this carbon is attached to 4 atoms. So this carbon is indicated by sp3 hybridization, and the second carbon, this one is attached to only 2 atoms. When a carbon is attached to only 2 atoms, then it is called as sp hybridization. Okay, here this carbon is similar to the one what we have seen here. So this carbon has sp2 hybridization, and this is the most beautiful molecule. We have 4 carbon atoms, and all the four have different hybridizations. First one, we have 4 atoms attached to this carbon, so this one has the hybridization of sp3. And then this carbon is attached to 3 atoms, so this one has the hybridization of sp2, and this carbon is attached to 3 atoms, hence it is also having the sp2 hybridization. And how about this carbon? This carbon has one nitrogen and one carbon is only attached to it, so this one is having the hybridization of sp, right? So remember that you have to check the hybridization of the particular atom. In this case, they have asked for the carbon. Most cases we will check for the carbon atom or the central atom of the molecule. All right, so from these examples you can have a summary or a short note, like when carbon is attached to 4 atoms, that is sp3. When carbon is attached to 3 atoms, then it is sp2. When carbon is attached to 2 atoms, then it is sp. Okay, so this kind of shortcut can be used by you to easily identify the hybridization of different molecules when the question is asked in the objective questions. Okay, let's move to the third one. Write the state of hybridization of carbon in the following compounds and shape of each of the molecules. This is one of the interesting questions. As usual, we have to write the complete structure of the molecule. Okay, C double bond O, H, H, and for this molecule C, H, H, H. Okay, and then for the third one we have to write, there is no different shape, so it could be like this one. Okay, so when we talk about the hybridization, we already know this short note, right? So when carbon is attached to 4 atoms, it is sp3. When carbon is attached to 3 atoms, that is sp2. When carbon is attached to 2 atoms, that is sp hybridization. Okay, so if you look at the carbon here, it has 3 atoms, so it is a sp2 hybridization. Okay, and how about here? It is attached to 4 atoms, so it is a sp3 hybridization. Then how about here? It is attached to only 2 atoms, hence it is sp hybridization. Okay, now let's go for the structure. Okay, what is the shape of the shape of these molecules? Okay, like this short note, there is another short note for finding out the shapes. When you have sp3 hybridization, the shape is most likely tetrahedral, and when you have sp2 hybridization, the shape is trigonal, planar, and when you have sp hybridization, the shape is usually linear. So this is hybridization and this is shape. Okay, you can note it down where you can remember easily, right? So let's look at the molecules. We are given sp2 hybridized molecule, hence its structure is trigonal planar. Okay, it has a structure of shape of trigonal planar. And how about this one? This one is having sp3 hybridization, so the shape of this molecule is tetrahedral. All right, and how about this one? This one has sp hybridization, hence it has a shape of linear structure. Okay, so like this you can solve any questions when they are asked. Always have the concept in your mind, because these are the questions which will be most likely asked in the objective type questions. Choose the best answer or the filling the blanks. So in those cases you are supposed to be answering in a quickest manner. You won't be having any time, so for that purpose only we are having this kind of short notes. Okay, let's meet in the next video with the other problems. Thank you.